This class makes you hyper? Because you're so excited about math? What are we on 3-5? And Weston, you said start with number 6? Okay. Thanks for your accommodating attitude. Matthew, you have a seat, please. All right, number 6. Oh, we did 6 yesterday, man. The last part where you subtract them? Okay, so what's this y coordinate? I mean, you can look at your thing. It's easier to see, maybe. What's this? We're redoing 6e, so you can relax while they get that figured out. What's this one? Y coordinate. Okay, what's 1 minus 0.2? Okay, so that means my new graph is going to have a point at 0.8. Then I'm going to go over to, yeah, we did do that. Then I'm going to go over to 1. What is this y coordinate? 0.5. Well played, sir. What is this y coordinate? 0.2. And 0.5 minus 0.2 is, so I'm going to put a dot in there at 0.3. And then finally, we'll scoot over here to number 2. What is this y coordinate? I think it's 0.25. Because I think they're getting cut in half every time. So it's 1, 0.5, and then 0.25. And then this one is still 0.2, of course. What's 0.25 minus 0.2? 0.05. So that's way down there. So this one is not a straight line because one of the curves is not a straight line either. So the graph looks something like that. Did you leave Talia yesterday? No. Okay. Yeah. No. Hey, time. Hey, time out on the field. This right here says bowling versus Aberdeen as if it were at home, but you guys had senior night. Are you going to Aberdeen tomorrow? Oh, okay. So yeah, that's what I figured. Yeah, I'll make that an app. And then you have districts is when? Next week sometime? Who knows? It says the 31st. Well, that's state. So you have to get through districts first. My calendar is not at all funky. My calendar is, whoa, excuse me, hello, goodbye. Yeah. Yes. I don't care. I don't care. Did it fit you? Yeah, perfect then. It's like a Harry Potter thing. It wasn't very detailed. It was short. All right. Wait, did we skip number 7? Did we? Where's number 7? There's no 7? Oh, awesome. All right. Number 7 is going to be on the test. Next one, for each context or representation, determine whether it is discrete or continuous, or could be modeled best in a discrete or continuous way. Number 8, Susan puts exactly $5 a week into her piggy bank. Yeah, let's do it this way, because these are ones I think you guys should be able to get a hold of. Sadly, no, it's discrete, but appreciate your enthusiasm. It's discrete because it jumps from $5 to $10 to $15 to $20 to $25. It doesn't go through the numbers in between. Okay? Yeah. I know, that was awesome. Oh, it's a graph of bouncy balls. That's fun. Whoops. Got a teamwork point there. Nathan? Nathan? Discrete or continuous? Porque? Why? Hey, hey, why? Okay. Yeah, and so Talia, that's why the other one would be discrete also, because if you made a graph of it, it would have a dot at $5 and then a dot at $10. But she, right, because she never had $7 in her bank. She put it all five in at the same time. Unless she put in like five $1 bills, then technically, no. All right, number 10, discrete or continuous? Continuous? Weston? Okay. There is a mathematical way. Right. Not dots. Throw that out there. All right, number 11. Marshall tracks the number of hits he gets each baseball game and is recording his total number of hits for the season in a table. So would that be discrete or continuous, Luis? Discrete, yeah, because you can't have like half a hit or a tenth of a hit. Nope. Yep, it's either a hit or it's not. Then it's not a hit, dude. You either have a hit or you don't. Are you guys referencing something from pop culture? All right, number 12, the distance you have traveled since the day began. I wish this was discrete. That would be cool. Nope. Riley, would this be continuous or discrete? Number 12, the distance you've traveled since the day began. Good. Can you give me a reason why? Yeah, right. There's always all the points in between the points. I was just writing down what you said because I was just being funny. Continuous because it goes on sort of through the time scale. Right. Oh, through. I said through. All right. How about the cost of gumballs? Continuous or discrete? Why? Okay, so what that means is that there's a pattern to it, but that's different than continuous or discrete. This is discrete because what he said, you can't have half a gumball. You can't. Right, so that's another way of thinking about it. It's discrete because it's all whole numbers. For it to be continuous, you could have decimals also, okay? Then I'm guessing the store would just give it to you for free. So there wouldn't be a cost involved. But even if you could say that situation, then there has to be like not just a half, but a quarter of a gumball, and a fifth of a gumball, and a tenth of a gumball, and a hundredth of a gumball, and that's not happening. All right, then last one. McKenna, Stephen, deposited what? Stephen, right, deposited $1,000 in a savings account at the bank when he turned 21. He deposits $100 each month. He plans to never withdraw any money until the balance is $150,000. Okay? I think this one you could go either way. If Yeah, if you are getting interest on your money, then it's going to be continuous. But if it's just $100, just like the piggy bank one, then it would be discrete. But it didn't say either way. Yeah, so that's kind of weird. What's that? Right. So I assume if you put it in a savings account, it's going to get interest, so it's going to be continuous. Okay. Yeah. All right. That's it for that. Yeah. All right. So lesson 6. What a surprise. We're looking at some graphs. We're talking about some values. We're increasing, decreasing. We're putting our phones away, participating in class. Given the graph of f of x, which I assume is this thing here, answer the following questions unless otherwise specified. Restrict the domain of the function to what you see in the graph. And you can approximate. Okay, so the first question is, what is f of 2? In other words, if I plug 2 into the function, what will I get as an answer? Jaron. If I plug 2 into the function, what do I get as an answer? They haven't told us what the function is. All they've done is given us the graph. But we can still use the graph to figure it out. How do you use the graph to figure out the value of a function at a particular point? Well, we could probably use our mad math skills to come up with a function and then plug it into that if we wanted to. But we can do it with the graph. Talia? Yes? Yes. So, Jaron, what Talia said is absolutely correct. What this question is really saying is if you go to 2 on the x line and then you go up to the graph, where do you hit the graph? Yes, McKenna, that is correct. I'm waiting on Jaron. I don't think that's necessary. Jaron? Shh, shh. What? Hallway. Jaron? If I go to x equals 2 and then go up to the graph, where am I on the... Oh, so if I go to 2 right here, and I go straight up to the graph, where's that? What? Jaron? 6. You see that? Okay. Okay, now we could do what Louise said, and we could come up with an equation for this graph. Matthew, are you with us or with them? No, you have to choose. Okay, you got to stay with us. You're welcome to join the... Okay. Then,
this is the best podcast ever.
Then be with us. Louise said we could come up with an equation for this graph, a function for it, and do it that way. What's the slope of this line?
3 over 2.
Good. Up 3 over 2, so that's y equals 3 halves x plus, where does it cross the y-axis? 3. Good. So if we could take that and plug 2 into there, 2 times 3 halves is 3, plus 3 is also 6. Okay? But we don't have to do that because we have the graph to use instead. Okay? All right, the next question then is asking the opposite. The next question is saying if the graph equals 3, what is x? Matthew? Yeah. If the y value is 3, what's the x value? Sharon? You're going this way again. What we want to do now is look at this point right here. Yeah, the answer is 0. Okay, right, I know. So this means the number inside the parentheses is the x. So this means plug 2 in for x. Tell me what you get. This means if you got 3 as an answer, what did you plug in to get it? Okay? Okay, next thing, what is the x-intercept? That should be fairly simple. Luis? What's the x-intercept? -2, yep, just where it crosses the x-axis. Okay, what is the domain? We've talked about that quite a bit. That's all of the possible x values. Nathan, what's the lowest x value? And the highest? Good. And since they have closed dots at both of those, I'm going to use square brackets. Yep. All right, we haven't really talked about this, but no better time than the present. Where is the graph greater than 0? In other words, where is the graph positive? Where is the graph above the x-axis? Where does it cross the x-axis? -2. And then does it go above it or below it after that? Above it. So that means on what intervals is it greater than 0? From -2 to 6 is where the graph is positive. Please stop. Above the x-axis. Okay? All right. On what intervals is the graph increasing? Talia? Sure. So let's pretend that this is like a trail that you're walking on. Where are you going up? So I'm going to start right here, and I'm going to start walking. I'm going up, right? How far? How long do I go up for? Good. From -4 to 6. Yeah. Talia, where am I going down? Oh, but I can't go backwards. Because then I trip and fall down the hill. What's that? You don't. Yeah. You get to the top of the hill, and you are stuck there for all eternity. Okay, then where is the graph greater than 3? We did greater than 0 already. Now we need to find where it's greater than, greater than 3. So Weston, for what values of x is the graph greater than 3? Nope. This would be, you just look at the graph and find where it equals 3, which is right here, right? And then where is the graph above that green line? But it starts at what x value? Yeah, nope. Starts at 0. And then it's above the green line all the way till x equals what? Oh, we're looking at the x's. 6. Okay. So it's greater than 3 from 0 to 6. That's probably supposed to be open because it says greater than but not equal to. But okay, what's that? Technically, I think the 0 should be a round bracket and the 6 should be closed, but I'm not going to, worry too much about that. Yeah. No. No. You might get a little sad face. You might get a little sad face. I might go home and cry a little bit. You never know. Okay, next one. So consider the linear graph f of t and the nonlinear graph g of t for these questions. First question, where are they equal? And this time, since we have a linear graph and a nonlinear graph, there's actually 2 places, Riley, where they are equal. What are the coordinates of the points where those graphs are equal, where they cross? If you're having a hard time seeing all the way up here, remember you do have this in your packet that you could look at right in front of you. Okay, you do you. No, don't listen to Nathan. That's just, I mean, like you guys sort of picked your senior quote already, but your senior quote could be, don't listen to Nathan. Because pretty much he's wrong. Okay. Anyway, what are the coordinates? What are the coordinates of that point, Riley? -2. Yep, and then this one has 2 points of intersection. What are the coordinates of that point? Yep, good. So they are equal at -2, -1, and then also at 3, 4. Okay? Yeah, let's talk about that, huh? Okay, Matthew. Next thing says, where is f of t greater than g of t? So that means we're looking for where the straight line is above the parabola. I disagree. Yeah, the entire middle section, which goes from... Right, good. These intersection points defined. So in between here, this is greater than that because it's above it. Over here, this is below that. And over here, it's below it also. So we really, Matthew, only need the x coordinates for that. So it's from -2 to 3. Yeah, that's fine. All right, next one. What is f of 0 plus g of 0? So now you have to figure out what those two things are and then add them together. So, Jaren, if I plug in 0 to the f function, what do I get as an answer? So this is basically the same question as you had before, so this is good. Give you a little chance to practice that. For the f function first. Right, don't listen to Nathan. What is g of 0? Because if I go to 0 on the x-axis and then I go up to the graph, I hit the graph at y equals 1. Okay, so now same thing, but I'm going to go to the g function. So it's -5. So Nathan, you were doing g of 0. So I know you're on the right track, but it wanted f of 0 first. Okay, next one is the same thing, but now we're finding the values at -1. I'll show you. That's okay. What is f of -1, Nathan? So what that's asking, Talia, is if I go to x equals -1, right, but it's the same thing for this, it's just -1 instead of 0. So if I go to x equals -1, and then I go to the f function, the straight line graph, what's the y value when x equals -1? What you got? What is f of -1? 0 plus, what's g of -1? G is the parabola. Yep. Yep. So if you add those together, you get -4. Okay, so this point right here is -1, 0, right? So here's the -1, and the answer is 0. Yep. Then this point right here is -1, -4. Here's the -1, here's the -4. Okay? You good? All right, Talia, which is greater, f of 0 or g of -3? So what is f of 0? What is the What is the y coordinate of the point 0 what on the... Yeah, so this point right here has the coordinate 0, 1, right? So that means f of 0 is 1. Okay? Now for the g graph, if we go over to 1, 2, negative 3, and then go up to the graph, what's the coordinate of that point? Right, negative 3, 4. So which one of those is bigger? F of 0 or g of it? Yeah. So that one is bigger. Am I stressing her out? Okay. It'll be all right, Julia. We'll get there. All right, then the last one says graph f of t plus g of t, but only from negative 1 to 3. So this is where we just add the y coordinates together. So what's this y coordinate? The y coordinate. And the y coordinate right here is 0. So if you add those together, 0 and negative 4 is negative 4. Then, Lindsay, then if I go over here to 0, what's the y coordinate there? Negative 5. What's the y coordinate here? 1. And if you add those together, what do you get? Negative 4 again. That's kind of weird. If I go over to here, what's the y coordinate of this graph at 1? Right, negative 4 and 2. If you add those together, you get negative 2. Then if I go to 2, what's the y coordinate of that one at x equals 2? And the y coordinate of this one is, which if I add those together gives me 2. And then finally, at 3, both of the y coordinates are 4. So if I add those together, I get 8. So look, I don't know, something like that. Not a coffee drinker. Yeah, I mean, right, that doesn't really count for much. I have a smoothie for breakfast. Yeah, smoothie and a little peanut butter toast to get some protein. No, I need so much sugar. No, that's bad for you too. All right, so now, Talia, this is going to help you because the last two problems, we were doing this from a graph. Now we're going to do it from a table, okay? And hopefully this will make the connection a little bit better for you. So the first question says, what is g of negative 3? So it's, Matthew, it's just like the graph. You go to negative 3 on the x, and then you go to the g function, and you get negative 5, okay? So it's exactly like the graph. The graph is just a little bit more challenging because it doesn't actually tell you those numbers. You have to find those numbers yourself, okay? Okay, what's that? Let's hope so. Okay, next one. For what values is f of x equal to 0? So, no, here's the f of x column. Where does it equal 0? Right here. So, no, because we're always looking at the x's. So, 1 and, oh, values, because there could be more than 1. So it would be 1 and 2. Yeah, it's at x equals 1 and x equals 2. Okay? All right, for what values does f of x seem to be increasing? So if you look at the numbers on this table, going down, 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 levels off, and then starts to go back up. Yeah, from 0, 2, 6, 12, and 20. So what are the x values where that's happening? From 2 to 6. Yeah. No, you're looking at G. They're asking about F. This is when the leveling off happens, yeah. Yeah. So for what values of f of x seem to be increasing from 2 to 6? I don't know if that's square brackets or round brackets. Good one. Thanks for bringing that up again, Dylan. So now we can have that 15-minute conversation. Okay, next one. On what intervals is g of x greater than f of x? So, what do you got? Well, I'm going to say starting at 0 because I know what you're saying because like right after -1 it could start. But we don't know really what's happening between -1 and 0. So as soon as we can say that is right here. So that would be from 0 to 6, yeah. Oh, I doubt it. Do what? Yes. Yeah. People eat bugs all the time. Yeah. Like what? Like mussel, you mean? Yeah. Like grasshopper legs or whatever? Yeah. All right. Number 19. Which function is changing faster from -5 to -1? So if we look at f of x, at -5 it's 44. At -1 it's 6. How much did it change? A lot. It went down by 38. If I look at g of x, it started at -13 and then at -1 it equals 3. How much did that change? Yeah, only 16. So who's changing faster? F of x. Nope, that's something different. Hello, turn the page. Okay. Okay, so first question was using graphs. Next one was using tables. Now we're using functions. Okay, yeah, equations. All right. So number 20 says which of the above relations are functions? That's a horizontal line, so that's okay. Okay. So all of them are functions except for x equals 4. X equals 4 is a vertical line, so it fails the vertical line test. Everybody else is fine. Okay. So 21, when it says find f of 2, g of 2, and h of 2, that just means plug 2 into those three functions. So what do you get when you plug 2 in for x in the f function? 4. What do you get when you plug 2 in for x in the g function? Plug in 2, what did you say? The g function. The g function. What does the g function do? No. The g of x equals 8. So that function, it doesn't matter what you plug in, you're always going to get back 8 as an answer. It's a boring function. But it doesn't matter. It's always 8. Because that's what it says. G of x equals 8. Yeah, no matter what you put in, it's always going to... What? No. What I'm saying is the g function doesn't do anything. It just gives you 8 as an answer. Okay? Yeah, it's a horizontal line. There's no x right here, so it's never going to change its value no matter what you put in. The reason why this changes is because there's an x there. So if you put in a different number for x, when you go 3 times that number minus 2, you're going to get a different answer. Okay? Same thing with h. When you plug 2 in there for x, what do you get? You're plugging 2 into the function for x. Right. Why? Because 2 to the second power is 4. Okay? So this function right here is saying, Matthew, this function right here is saying, just like you said, whatever number I plug in, I'm going to raise 2 to that power. This function is saying whatever number you plug in, I'm going to multiply it by 3 and then subtract 2. This function is just saying whatever number you plug in, I'm just going to still give you 8. It doesn't. Okay, yeah, it's a weird one. All right, write the equation for g of x plus h of x. 8, because that's what g of x is, plus 2 with an x, 2 to the x. Yep, good. All right, number 23, where is g of x less than h of x? Where does h of x equal something bigger than 8? Where does it equal 8? What number would you have to plug into the h function to get the answer 8? 2 to the what power is 8? 3. Okay, so when x equals 3, the 2 are the same. Okay? So when is h bigger than that? For bigger numbers of x or smaller numbers of x? If I plug in, so like if I plug in 2, then 2 squared is 4. Is 8 less than 4? No, other way around. So above 3. So that would be from 3 to infinity, I guess. Okay? All right, 24. Where is f of x increasing? Good. Everywhere. How do you know? Oh, okay. Yep. You plug in 1, you get 1. There's no, well, there's a minus 2. What does the 3 tell us about that graph? And what is, so in the like y equals mx plus b situation, what is the 3? The slope. And is that slope positive or negative? Positive, and so that means you know it's increasing. Yeah. So that's increasing everywhere, from negative infinity to infinity. And beyond. What? Did you say something? What? I didn't make a noise. Yeah, so we could check and know that I'm not lying. We could check the tape. All right, 25. Which of the above functions has the fastest growth rate? You throw a challenge flag on me, Matthew? You go back. Which of the above functions has the fastest growth rate?
Yes.
F of x is going up by 3 each time. Okay, so that one's going up by 5. Yep, so that's definitely faster than 3. What about h of x? What's that doing every time? Yeah, it's a power function, so it's doubling every time. So that's going to be the fastest one. Okay, so we did these types of problems looking at graphs. We did these types of problems looking at tables. And we did them looking at functions. So good for us. Okay, now we're going to do these using words. Okay, so how much room do you guys have for these? None? Okay. Yeah, this seems like another, like a new piece to the puzzle. So yes, I agree with Weston. Let's take this up tomorrow, okay?